In this video, we'll be creating the boards class. For our instance data, we will have two boards of type character double array, as well as counters for the player's ships, as well as counters for the computer ships. So first we have the character double array of first board. So the board is essentially a 10 by 10 board with a top row and a first column of labels 1 through 10 or 1 through 9. So it will be size of 11, row and column. And same thing for board B. And we also need counters for the player's ships and the computer ships. Now we are ready to create our constructor. In this constructor, we'll be initializing board A as well as board B. And we'll be creating methods in the future for these initializations. Now we'll be creating the method init board A, which initializes the first row and column, which specifies the index as well as the rest of the board. And here I'm using the character unifloat values, which correspond to the numbers 0 through 9. And I'm casting this into a character. Now we'll be taking care of the first row of the board. And this will be for the rest of the board. And we'll initialize it with A. And that's our board A initialized. We can initialize the same way for board B, but be sure to change all of the variable names to board B. And that's our board B done. It was simple as that. Now we will be having the method isValidLocation, and this will take into consideration the ship size and direction, as well as the fact that the ships cannot overlap, and it assigns the location as valid or not in order to place the ships. First, we need to make the +1 offset of each of the coordinates, x component and y component, to take into consideration the first row and first column that we used to create the labels instead of the actual game. Same thing goes for the y coordinate. Now we'll be checking if the coordinate is outside of the board boundary. Same goes for the y coordinate. So now, after that, we will be checking the case of if a ship is placed on the board and if that is a valid ship location. So we're going to be checking all the cases of all the directions. And I'll explain that as we go on. So if the ship's direction is pointed upwards, we want to check if the front of the ship's coordinate is outside the grid or not. So if the y coordinate So here we're saying if the y coordinate that we have up here as a parameter, if we subtract that from the ship size, if that is outside of the board's boundary. If it is outside the board's boundary, it's going to return false, as that is not a valid location. But if it is a valid location inside the board, we want to check if there's any other ships during those places or at those places as well. In order to have an empty location for where the ship can be placed, there needs to be a slight that symbol, that squiggly symbol here. And if it's not there, that means that there's a ship presiding in that very ship's location where you want to put it. But that's not possible, so we'll return false. And the same goes for all of the other directions, if it's up, down, left, or right. Else, if the direction is downwards, then we're going to be adding the size downwards. And if that is greater than or equal to the bottom boundary, which is the length of the board, then we're returning false. And we want to make sure that there's no ships on the locations where we want to place our ship. So we're going to be going through all those locations to make sure that there's no other ship presiding in that location. Next, we're going to be taking the condition that it's going to the left or to the right. Right. then we're going to be dealing with the x coordinate. And this needs to be either greater than or equal to the length of the row, which is going to be board A at 0. Next, we want to tweak this for loop. So we're talking about the x coordinate. If I is going to be less than or equal to the x coordinate plus the size of the ship minus 1, or to account for the front of the ship. And we're going to be adding. So if board A at the y coordinate I is not equal to that squiggly symbol, that means there's a ship residing in that same location, and we want to return false. And last, for the final direction, else if s dot get direction is equal to left, then we're going to be checking if the x coordinate is outside the initial first column boundary. And we're returning false if that's true. If it's a valid location, we're going to be looping through all of the coordinates of the ship and see if there's already a ship residing in that location again. Any of these coordinates, there's a ship that's going to return false. And if neither of those conditions are true, that is a valid location, and we are returning true. And this is the finished is valid location method. The next method that we're going to make is the method called is valid attack. So similar to the method before, which was is valid location, we're going to be checking if the coordinate where you want to attack is a valid attack inside the board's boundary. So we have the coordinate as our parameter in this case. First, we need to always make sure to remember that we need to offset our coordinate because of our first row and first column that we used for labeling our board. And same thing for the y, for the x. Now we're checking if the coordinates are inside the board's boundary or outside. And if neither of those are true, that is a valid attack, and we are returning true. Now we're going to be making the method called result hit miss computer, or result hit miss com. And this is going to outline the code and background for when you as a user are going to be attacking the computer. It's going to be returning a char, result hit miss computer. And I'm going to make these class method names as detailed as possible so we know what they do when we use them later on in other classes. So as parameters, we're taking the actual coordinate which you're attacking, as well as the opposition, which is the computer you're playing against. So obviously first we need to offset our coordinates, which I'm just going to copy the code up here, down here. And now we need to see if whatever coordinate that you enter, if the ship on that computer's board, it's going to take note of that type of ship and increment the counter of that ship. And for this computer error here, don't worry about that for now because we don't actually have a computer class at the moment. We're going to be making that in the future. If that is equal to A, which is an aircraft carrier, we're going to be incrementing the number of aircrafts on the computer board. And if this number is equal to 5, that means that the user has sunk all components of that aircraft ship on the computer's board. So we will output the message that you sunk your opponent's aircraft carrier. The same goes for all of the other ships. If it is equal to a B, or in other words, a battleship, the number of a battleship on the computer side is incremented. And similarly, if the battleships are equal to 4, because that is the size of the ship, we're going to be outputting this message. And we could just use the copy and paste method because this is some repetitive code. If it is equal to S, the number of submarine on the computer's board is incremented. If that is equal to 3, the same goes for the destroyer ship. And lastly, troll ship. So after all of this, we want to see if the coordinate that you are attacking, if that is a hit or a miss. So if the coordinate where which you attacked is not empty, then that is a hit. And don't worry about this error here, because we're going to be making that method afterwards. So if that is a hit, that means on the opposition's board, at those same coordinates, there's going to be an X, because and we're returning the result of hit. Now, if we don't hit the ship, that means it's a miss. That's going to be F for miss, and we'll return. Next, we're going to be doing the same thing, but for the player. So we're going to be making a method called result hit miss player. Parameters of a coordinate, as well as the player opposition in this case. Instead of the computer last time, it's now the player opposition. The computer's perspective. And this player, we're going to be making that class later on. Again, we need the offsets. And now we are going to be doing the same thing, counting the increments of the types of ships and seeing if that is a hit or a miss. So with the same code, we will just tweak this code we have written earlier. So this if statement stays the same, but we're changing the type of ship that we're counting. So instead of the computer ship, we're counting the player ship. And this will be the result that your opponent sunk battleship, to make it more personal. And so after that, we will check if it is a hit or a miss. If this is not equal to an empty space, that means it is a hit. And we're marking an X here. Now we're going to be making the method that will print out the result of the attack to the player. So if the result is a miss, we'll print out a failed message. Oh, that means the result is a hit, and we'll print out a success message. The next method we're going to be writing is the place ships method. And this will actually place the ships, which is in the parameter, onto the board at the specified coordinate. So again, we need to make the offset whenever we're working with a coordinate. And so whatever coordinate that the parameter is referring to, that is the front of the ship. So we will place the ship's letter at that position. Then, depending on what direction the ship has, the method will go through the length of the ship in that specified direction to place that ship's letter onto the board in those spots. So if the direction of the ship is towards the upwards direction, we'll go through those specified spots, starting from a coordinate and going upwards on the board. And at those locations, we will be placing the ship's letter. I'll step the direction. It's the downwards direction. We'll be going through similarly and changing and tweaking. X, if the direction is pointed to the right, we'll be going in the X direction. And same thing for the last direction, the left direction. Now we will make our getter methods, getting each of the boards. Same thing for board B. And the last two methods will be printing out each of the boards. And same thing for board B. And that is our finished boards class. This was a lot, but hopefully you got through it. And next time we'll be going through the players class. Thank you.